Oh yeah, welcome back to my channel. And 2 videos ago, we reviewed use of introduction to derivatives in economics. So those functions were very basic functions, and most times questions will not come as simple as that. They will come where you have to apply the other rules of differentiation or the basic rules of differentiation. So in this video, we're going to be going over the 3 rules of differentiation, namely product rule, quotient rule, and chain rule, respectively. So let's start with product rule. So imagine you have a function like this: 6x squared plus 5, close brackets, multiplied by 4e to the 2x. How do you evaluate the derivative of this function? So if you look at this function, compared to the other functions we dealt with in the previous video, you see that this one is quite complex, and it's more composite because it has 2 different functions multiplying each other. The first function being 6x squared plus 5, and the second function being 4e to the power of 2x. So how do you find the derivative of this function? Now this problem is a product rule problem. So the note, you always use the product rule whenever you have 2 distinct functions multiplying each other, like this one. 6x squared plus 5 is a function on its own, and 4e to the power 2x is a function on its own too. So whenever you have 2 different distinct functions multiplying each other, remember to use, or whatever should come to your head should just be the product rule. You're going to use the product rule from the name product. It's when 2 different things are multiplying each other. So this is not the only way product rule could come out in. It can come out in various ways. Just note the key, the common factor is that 2 different functions multiplying each other. Imagine you have a function like 5x squared plus 2 or raised to power 2 multiplied by 6x. You can see that 5x squared plus 2 is a function on its own, and raised to power 2 rather is a function on its own. Then 6x2 is a function on its own. So when 2 different functions are multiplying each other, always remember that you're supposed to use the product rule to solve that question. Alright, so let's solve this question. So how do you solve questions using the product rule, under the product rule, or using the product rule? Use the simple formula: dy by dx is equal to u dv by dx plus v du by dx. So this is the formula, where u is the first function and v is the second function. But it really doesn't matter which one you pick as your u or v. You can choose this to be your u or this to be your u. You could also choose this to be your v or this to be your v. It doesn't really matter. You just choose one of them to be your u and your v. So let's solve. So for this function, we have y equals 6x squared plus 5 multiplied by 4e to the 2x. So let's choose this to be our u and this to be our v, right? So let's write them out. Say let u equals 6x squared plus 5. And the next thing we need to do is we need to differentiate u with respect to x. So our du by dx, remember your power rule, 2 comes to the back, it becomes 2 times 6x raised to the power 2 minus 1. Then plus, remember the derivative of a constant is 0. Why? Let's just refresh your memory. Remember 5 can be written as 5x raised to the power 0, because anything raised to the power 0 is 1, and 5 times 1 is consequently 1. So if we use the power rule on this, it becomes, let's write the arrow here, it becomes 0 times 5 raised to the power x, all the times x raised to the power 0 minus 1, and 0 times anything is 0. So our du by the x is equal to 2 times 6x then plus 0, right? So our du is just 12x. So I've done the first step. So the second step is to deal with the v function that we already established. So remember we said let v equal 4e to the 2x, right? So we need to differentiate v to get our dv by dx. Now we see that this is an e function. Remember, one thing to remember is the derivative with respect to x or any variable of e to the x is just equal to e to the x. The derivative of e to the ax, where a is a constant, is equal to a times e to the ax. Just remember that formula. So if you have something like e to the x, the derivative of e to the x is e to the x. If you have something like e to the 2x, like we have here, the derivative of it is just going to be what? From the formula, 2 times e to the 2x, and so on. If you have something like e to the 5x, it's just going to be 5 times e to the 5x, and the pattern just goes on like that. Let's apply that into this function. So If we're differentiating this, remember we said it's just going to be 4, then 2 comes to the back times 2 e to the 2x. Remember from this. So our dv by the x is just going to be 8e to the 2x. Do you get it? So now we have our dv by the x, have our du by the x. So we can just plug that back into the formula. So our dy by the x is equal to, remember, u dv by the x plus phi du by the x, where dv by the x and du by the x are the derivative of the functions u and v respectively. So our dy by the x is equal to what? Remember we said we said let u equal 6x squared plus 5. So this is just going to be 6x squared plus 5, and dv by the x is 8e to the 2x. We already established this, multiplied by 8e to the 2x, then plus v. We set v to be 4e to the 2x. So 4e to the 2x multiplied by our du by the x, and that was what? 12x. So let's simplify this. Our dy by the x is just going to be 8e to the 2x multiplied by 6x squared plus 5, then plus 12 times 4 is 48. So we have 48e to the 2x. Now we can factor out 4e to the 2x, or rather 8e to the 2x. Can we factor out 8? No, we can't factor out 8. We could either leave our answer like this, or we could factor out e to the 2x. So what is common in 8 and 48? Oh, 8 is actually common, so we can factor out 8. You can factor out 8. You can also factor out e to the 2x since they both are present here. So we have e to the 2x, then into bracket 6x squared plus 5, then plus this is just going to be 6. So this is our answer. So you can leave your answer like this. 8 times 6 is 48, then times e to the 2x here. That's how we have an answer like this. So our answer is equal to 8e to the 2x, open bracket, 6x squared plus 5 plus 6. So this is our final answer. That's how I use the product rule. Let's take another example to solidify your understanding of it. Yeah, so look at this question now. Imagine we have a function y equals, into bracket, 9x cubed plus 6x squared plus 14, close bracket, multiplied by 16x to the power 7 plus 6x raised to the power 2 plus 3. I'm asked to find dy by the x. See, this is a typical example of product rule. Why? Because we have two distinct functions multiplying each other. So instead of just expanding them one by one and then differentiating again, you can just use the product rule. And I said what? Dy dx for the product rule, dy dx is equal to u dv by dx plus v du by dx, where dv is derivative of the function you choose as u, and du by dx is derivative of the function you choose as your u. So this is the derivative of your u function, this is derivative of your v function, sorry, and this is derivative of your u function, while u and v are the original functions respectively. So what do we do? So let's take this function to be our u and take this function to be our v. So if our u is equal to 9x cubed plus 6x squared plus 14, what do we do to get du by dx? We just differentiate it. Very simple. So our du by dx, remember our power rule, 3 comes to the back, this becomes 3 times 9x squared, then plus 2 comes to the back for 6x squared, so this becomes 2 times 6x, then plus derivative of the constant 14 is 0. So our du by dx is equal to 3 times 9 is 27, so we have 27x squared plus 2 times 6x is 12x. So this is our du by dx. Hope that's clear. So let's deal with our v. We said this function should equal v, right? So our v is equal to 16x raised to the power 7 plus 6x squared plus 3. So what do we do to get our dv by dx? We differentiate it. So our dv by the x is equal to 7 times 16x raised to the power 7 minus 1 or 6 plus 2 comes to the back, 2 times 6x raised to the power 2 minus 1 or 1, then plus the derivative of the constant is 0. So dv by dx is equal to 7 times 16. 7 times 10 is 70. 7 times 6 is 42. 70 plus 42 is 112. So we have 112 x raised to the power 6. 7 minus 1 is 6. Then plus 2 times 12. 2 times 6, sorry, is 12. X raised to the power 1, or just x. Then plus 0, you can choose not to add that. So our dv by the x is 112 x raised to the power 6 plus 12x squared. Yeah, so we have our u to be 9x cubed plus 6x squared plus 14, and our v to be 16x raised to the power 7 plus 6x squared plus 3. And we found our du and dx respectively. So you can plug those values into the function or into the formula. Dy by dx is equal to u dv by dx plus v du by dx. So our dy by dx is equal to, what's our u? Our u is 9x cubed plus 6x squared plus 14. So let's put that into brackets. 9x cubed plus 6x squared plus 14. And our dv by dx is 112x raised to the power 6 plus 12x. So we have 112 x raised to the power 6 plus 12x. Then our plus. Then what's our v function? Our v function was 16x raised to the power 7 plus 6x squared plus 3. So we have 16x raised to the power 7 plus 6x squared plus 3 multiplied by our du by dx, and du by dx was 27x squared plus 12x, as we established here. So we have 27x squared plus 12x. So our dy by dx is equal to 9x cubed plus 6x squared plus 14 multiplied by 112 x raised to the power 6 plus 12x, then plus 16x raised to the power 7 plus 6x squared plus 3 into bracket 27x squared plus 12x. So this is our final answer. You leave your answer like this, because expanding it is going to take your time, so just leave your answer like this. So yeah. So let's take one last question. Let's say we have y equals 40x cubed times e to the minus x squared. Yeah. I will ask to find the derivative of this. Remember I said use this product rule when two distinct functions are multiplying each other. Here we can see that 40x raised to the power 3 is a function on its own, and e raised to the power minus x squared is a function on its own too. So we're going to use what? The product rule. And I said again, the product rule, remember the formula, dy by dx is equal to u dv by dx plus v du by dx. Don't forget this formula. So let's choose one function to be our u and the other one to be our v. It doesn't really matter. You can choose anyone to be your u and v. The order doesn't matter in product rule. You can choose anyone to be your u or your v. So let's choose, let's change the order today now for this question. So let's say u equal to e to the minus x squared. Now, how do we differentiate e to the x squared? Remember I said if we have a function e to the x, the derivative of e to the x is just e to the x. Why? It's because the rule is just that you are just multiplying e by the derivative of x, and the derivative of x is just 1. So 1 times e to the x is e to the x. So if you have something like e to the 2x, we'll just differentiate 2x and multiply e by that value. So the derivative of 2x is what? 2. So we have 2e to the 2x. So that's just the pattern as I explained in the former function. So imagine we have something like e to the x squared, and we're looking for the derivative of this. What do? We just differentiate the power or the exponent, that's x squared. So if we differentiate x squared, we just have 2x. Remember from your power rule, x squared becomes 2 times x raised to the power 2 minus 1, and x squared equals 2x. That's the derivative. So if we have a function e raised to the power x squared, if we just differentiate our power, that's the x squared, we have just 2x. So we multiply it by that function again. That's going to be 2x times e to the x squared. So that's the pattern with e. Let's see what happens now. Let's say we have something like e to the x raised to the power 3, and we're looking for the derivative of this. Very simple. We differentiate this exponent, that's x cubed, and if we differentiate x cubed, we have 3x squared. Remember from your power rule. So we have 3x squared multiplied by e to the x cubed. So that's the pattern with the function e. So let's use that here. So if we have if we set our u to equal e to the minus x squared, what do we do to get our du by the x? We differentiate it. So our du by the x is equal to, I remember I explained here, just differentiate minus x squared, that's the exponent, and that's just minus 2x, then multiply it by the function e raised to the power minus x squared, and this is your answer. So we've settled out u and du by the x. So let v equal 40x cubed. What do we get? What do we do to get our dv by the x? We differentiate it again. So dv by the x is equal to 3 comes to the back, multiplied by 40x raised to the power 3 minus 1, and 3 minus 1 is 2. So our dv by the x is equal to 40 times 3 is 120. Yeah, so we have 120x squared. This is our dv by the x. So let's plug that into this fun formula right here. So remember we said dy by x is equal to u dv by dx plus v du by dx. So let's plug in our values. We have our u, we have our dv by dx, we have our v, and we have our du by dx. So let's plug that into the function or the formula. So dy by dx is equal to what? U, we said our u should equal e to the minus x squared. We changed the order to show you that it doesn't really matter. The order doesn't matter. So our u, that's just going to be e raised to the power minus x squared multiplied by dv by dx. dv by dx, we established it to be 120x squared. So we have 120x squared. Then plus our v is what? Our v was or is 40x cubed. So we have 40x cubed multiplied by du by dx, and our du by dx we established it to be minus 2x times e raised to the power minus x squared. So we have minus 2x e raised to the power minus x squared. So our dy by dx or y prime doesn't really matter. This is y prime is also a denotation for dy by dx. So yeah, take note of that. So let's expand this. So we have 120x squared times e raised to the power x squared minus x squared, sorry, then plus open bracket 40 times minus 2. Oh, we even have 2x's here. So 40x cubed times minus 2x is just going to be minus 80x raised to the power 4, because x raised to the power 3 times x raised to the power 1 becomes x raised to the power 3 plus 1, 4 from your laws of indices. And 40 times minus 2 is minus 80. Then e raised to the power minus x squared. So this is our answer. If you expand this, minus and plus multiply and it becomes minus. So our answer is, let's put it in a little bracket here, 120x squared e to the power minus x squared, then plus or then minus 80x raised to the power 4, blah 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 blah. So no space anymore, sorry about that. So yeah, this is our final answer. Yeah, so hope you understand the product rule. That's about how complex it gets with the product rule. Remember, the product rule, we use the product rule when two distinct functions, f of x and g of x, are multiplying each other. So don't forget that. So product rule for when two different functions are multiplying each other, and we solve it with the formula u dv by dx plus v du by dx. So that's about that in product rule. So let's go into another rule of differentiation called the chain rule. Okay, so let's go over the second rule of differentiation, the chain rule, also known as the function of a function. We use the chain rule when you have a function inside of a function. First, let's say we have something like y equals 6x squared plus 5. Now this is a function on its own. Then it's inside another function raised to the power 2. So they typically come in this type of order. When you have a function y equals 6x squared plus 5, that's a function on its own. And inside another function, all raised to the power 2. So how do we solve functions like this? We use the formula dy by dx is equal to dy by du times du by dx, such that the du's will cancel and we'll have dy by dx as our final answer. But how exactly do we know what to assign as our u and what to use as our x? Very simple. So let's take this example as a case study. This y equals 6x squared plus 5 raised to the power 2. So the first thing we need to do is we let u equal 6x squared plus 5. Then what do we do to get our du by dx? We differentiate it. So our du by dx is going to be 2 times 6x raised to power 2 minus 1. And the derivative of a constant is 0. So plus 0 if we just leave like that. So our du by dx is just going to be 2 times 6x raised to power 1 is just 12x. So we have our du by dx to be 12x. So remember we said let u equals 6x squared plus 5. So that means this place will be replaced with the variable u. So we have y equals u raised to the power 2. See, the goal of the chain rule is to simplify a composite function like this into one variable like u to make it easier to treat or to differentiate. So since we already set our 6x squared plus 5 equal to u, what we'll have is just a y equals to u squared, and this is way easier to differentiate than something like this. Do you understand? So what do we do to get our dy by du from this formula? We just differentiate our y with respect to u. So dy by du is just going to be 2u raised to the power 2 minus 1, or just 2u. So now we have our du by dx and we have our dy by du. So we can now plug that into the formula. So our dy by dx is equal to du by dx, dy by du rather is 2u, then multiplied by du by dx is 12x. So when we multiply everything, we have 24xu, right? And what exactly is our u? Our u was 6x squared plus 5. So our dy by dx is just going to be 24x multiplied by 6x squared plus 5. Hope that's clear. So another simple way to solve this question is, there's a trick. Now we said we have y is equal to 6x squared plus 5 raised to the power 2, right? Now one simple way to differentiate this function, let's say you have an objective exam. Very simple, you just take this 2 to the back. This is 2. Then maintain the function 6x squared plus 5, right? Then 2 minus 1, remember from the normal power rule. Then multiply by the derivative of what is inside here. And the derivative of what is inside here is just what? The derivative of 6x squared is 12x, right? And the derivative of 5 is just 0. So we multiply that by this. So our dy by dx is equal to 12x times 2, that's 24x, then 6x squared plus 5 raised to the power 1. See? Exactly the same answer. So that's one trick to use to solve it. Let's take another example. Let's say we have something like, let me think of a more complex function so we can solidify our skills on it. Let's say we have something like y is equal to, let's say we have something like y is equal to 6x raised to the power 5 plus 1 all raised to the power of 9. Yeah. So what do? We need to find a way to simplify this function, this inside function, to become a single variable, which will in turn make the equation or the function easier to differentiate. So let's say v equals 6x raised to the power 5 plus 1. To get our dv by dx, what do? We differentiate v, right? So dv by dx equals, this becomes 5 times 6x raised to the power 5 minus 1, then plus 0, since the derivative of a constant is just 0. So dv by dx is just going to be 30x raised to the power 4. So yeah, you understand that. So what do we do now? Since we already set this place to equal u, this function can be rewritten as y equals u raised to the power of 9. So we say that this is easier to differentiate now. So our dy by du is just going to be what? 9 times u raised to the power 8. So now we can plug this into the formula. So our dy by dx is going to be dy, sorry, this is v, this is v, we said this equal v, sorry. So our dy by dv, not du, sorry. So you can use any variable for this. It could be v, it could be u, it could be w, it could be z, whatever. So this du could be any variable of your choice. It doesn't necessarily have to be du. It could be the k, the s, the v, whatever your choice. So dy by dv times dv by dx. So Our dy by dv is 9v raised to the power 8. So we have 9v raised to the power 8. Then multiply by dv by the x we had to be 30x raised to the power 4. 30x raised to the power 4. So our dy by the x is equal to 9. We said our v equals 6x raised to the power 5 plus 1. So we have 6x raised to the power 5 plus 1. Then multiplied by 30x raised to the power 4. So let's simplify this. 30 times 90, that is going to be 270. Yeah. So we have 270 x raised to the power 4 multiplied by 6x raised to the power 5 plus 1. So you could either choose to expand or leave your answer like this. So yeah, that's as chain rule. Let me think of one more complex function. So we'll solve that and we'll go into our question rule. Alright, let's treat one last chain rule question before we go into our question rule. So imagine we have a question: y equals 45x raised to the power 4 plus 1 or raised to the power 1 over 2, or written as y equals the square root of 45x raised to the power 4 plus 1. Remember, anything raised to the power 1 over 2 just means square root. So or you can pause the video and try this question for yourself, and when you're done, compare your answer. So this is another chain rule question. So we can rewrite this as y equals 45x raised to the power 4 plus 1 or raised to the power 1 over 2. So remember I said find a way to, we always in chain rule, we basically use the chain rule to simplify complex or composite functions to make it easier to differentiate. So let's try making this big O function a simple variable like u, so it will be easier to differentiate. So let u equals 45x raised to the power 4 plus 1. So you can try differentiating this by yourself, and when you differentiate it, we have du by the x is going to equal 4 times 45, 4 times 40, that's 160, 4 times 5, that's 20, 160 plus 120, that's just 180. So we have 180 x raised to the power 4 minus 1, then plus 0, since the derivative of any constant is just equal to 0. So our du by the x is equal to 180 x raised to the power 3. So remember we said this function inside to equal u. So by implication, our y is going to equal u raised to the power 1 over 2. See that this is way easier to differentiate, right? So if we differentiate our y with respect to u, our dy by du is just going to be 1 over 2 u raised to the power 1 over 2 minus 1. Remember your power rule, don't forget. So our dy by du is just going to equal u raised to the power minus 1 over 2, then divided by 2, since you get it from this, right? U times 1 over 2 is just going to be u over 2, so it doesn't really matter. So our dy by, so let's write out what we have. So our dy by du is equal to u raised to the power minus 1 over 2 over 2, and our du by the x is equal to 180 x raised to the power 3. So let's plug this into our formula. What's the formula? Remember, in the chain rule, dy by the x, that's a function of a function, that's the chain rule. We have dy by the x to equal dy by du times du by the x. So we already have our contestants for the answer. We have our candidates rather. So let's plug them into the equation of the function. So our dy by the x is going to be dy by the u is u raised to the power minus 1 over 2 over 2. So we have u raised to the power minus 1 over 2 over 2. And multiplied by du by the x is 180 x raised to the power 3. So we have times 180 x cubed. So let's simplify. Our u, remember, was equal to 45 x raised to the power 4 plus 1. So we can just plug that back into the function. So y by the x is equal to 45 x raised to the power 4 plus 1 or raised to the power minus 1 over 2 divided by 2, then times 180 x cubed. So let's find a way to simplify this particular function. So let's write it. Dy by the x is equal to so remember I said the any function or any value raised to the power 1 over 2 just means the square root of that value from your laws of indices. So we can rewrite this as 1 over the square root of 45 x raised to the power 4 plus 1 all divided by 2. Why? Because of this minus here. Remember, anything raised to the power minus 1, for instance, x raised to the power minus 1, just equal to the reciprocal of that. That's 1 over x. So, with this function here, the logic behind this is, if you have something like 45 x raised to the power 4 plus 1, or raised to the power minus 1 over 2, we could also rewrite this to be equal to 45 x raised to the power 4 plus 1, all raised to the power 1 over 2, then all raised to the power minus 1. From a lot of indices, these two will multiply each other. Let me get a clearer marker. So, from the law of indices, these two multiply each other and consequently give you this raised to the power minus 1 over 2. So, remember I said, let me rewrite this so you'll be able to see. Plus 1 raised to the power 1 over 2, then raised to the power minus 1. So, remember, so these two just multiply and it will give you this, so it's perfectly the same thing. Remember I said any function raised by 1 over 2 just means the square root of that function. So we could write this as the square root of 45 x raised to the power 4 plus 1, then all raised to the power minus 1. And anything raised to the power minus 1 is just means the reciprocal of that function or that value. This could be written as 1 over the square root of 45 x raised to the power 4 plus 1. So that's what we have here. Yeah, so that's the common sense behind this. So let's go back to dealing with this bad boy here. So our dy by dx is equal to 1 over the square root of 45 x raised to the power 4 plus 1 divided by 2 multiplied by 180 x cubed. So let's simplify this. So our dy by dx is equal to 1 over the square root of 45 x raised to the power 4 plus 1 divided by 2, then times 180 x cubed. So if we simplify this, this is going to 2 comes down and this changes to multiplication. So our dy by dx equals 1 over the square root of 45 x raised to the power 4 plus 1 multiplied by 1 over 2 times 180 x cubed. So 2 in here 1. 2 in 180 is just 90. So our dy by dx is equal to 1 over the square root of 45 x raised to the power 4 plus 1, then multiplied by 90 x cubed. So you could leave your answer like this, or you could simplify it again. So let's simplify it to make it exam styled. So dy by dx is just going to equal, you can write this to just be the same thing as this. So we just have 45 x raised to the power 4 plus 1 or raised to the power minus 1 over 2, then multiplied by 90 x cubed. So let's bring 90 to the front. So I'll divide by dx equals 90 x cubed times 45 x raised to the power 4 plus 1 raised to the power minus 1 over 2. So this is our final answer. I hope you understand the logic. This, remember I said 1 over anything just means the inverse of that stuff. So if we use the laws of indices to convert this, we could have 45x raised to the power 4 plus 1 or raised to the power minus 1 over 2. So I remember from the logic we established here. So then multiplied by 90x cubed, we just have this as our final answer. So the derivative of 45x raised to the power 4 plus 1 or raised to the power 1 over 2 is just 90x cubed multiplied by 45x raised to the power 4 plus 1 into brackets raised to the power minus 1 over 2. So that's that for chain rule. So let's go into the last rule of differentiation. That's the quotient rule. Alright, so let's go over the last rule of differentiation. That's the quotient rule. Now, relative to the contrary to the, or as opposite to the product rule, for the product rule, use the product rule when you have two different functions multiplying each other. For the quotient rule, it's quite different. Use the quotient rule when you have two different functions dividing each other. It's like when you have fraction of functions, like you have a function over a function. That's when you use the quotient rule, from the name quotient. So use the quotient rule for functions dividing each other or fractions of functions. So let's spare out that yapping jargons and let's take an example. Let's say we have a function like y equals 5x squared plus 2 divided by 6x squared plus 9 you see that these are just two functions dividing each other. This is a quotient, so we use the quotient rule for functions with this type of structure. So note, whenever you see two functions dividing each other, you use the quotient rule for that function. Alright, so let's take this example. So for the quotient rule, the formula is dy by dx is equal to v du dx minus u dv by dx divided by v squared. If you notice, in the product rule, the order of which one comes first doesn't really matter. It could be u dv dx or plus v du dx or v du dx plus u dv dx for the product rule. But for the quotient rule, it's quite different. The order matters. It is always v du dx minus u dv dx. So it doesn't. The order matters quite well in the quotient rule. So you have to take note of that. So let's treat this function. So what do we take as our u? What do we take as our v? So let's take this upper function as our u, lower function as our v. Please, let's always abide by this. Take the upper one as your u, take the lower one as your v. So if our u equals 5x squared plus 2, what do we do to get our du by dx? We differentiate it. So du by dx, let me get a better marker, please. So du by dx, is equal to 2 times 5x raised to the power 2 minus 1, and the derivative of any constant is just 0. So our du by dx is just equal to 10x, right? So remember we said our v to equal this. So if our v equals 6x squared plus 9, dv by dx is just going to equal 2 open bracket 6x raised to the power 2 minus 1, and the derivative of any constant is just 0. So our dv by dx is going to equal 12x, right? So now we have our dv by dx and we have our du by dx. We can now plug this into the formula. So the formula, dy by dx is equal to v du by dx minus u dv by dx. So let's plug in our values or our functions into this formula. So this is going to equal, our v is what? 6x squared plus 9. So we have 6x squared plus 9 multiplied by our du by dx. Our du by dx is exactly what? 10x. Yeah, we established that here. Multiplied by 10x, then minus our u. Our u is 5x squared plus 2. 5x squared plus 2 multiplied by dv by dx, and dv by dx we established it to be 12x. Then divided by v squared. Don't forget the formula. Divided by v squared. I forgot to add that here. Sorry, divided by v squared. So our v is what? 6x squared plus 9. So if we have 6x squared plus 9, then all raised to the power 2. So our dy by dx, that's the derivative of this function, is equal to 10x open bracket 6x squared plus 9 minus 12x open bracket 5x squared plus 2, all divided by 6x squared plus 9 squared. And my marker is gone. So that's basically it. So let's take another example for example sake. Let's we have something like y equals 5x squared plus 2 raised to the power 2 divided by 6x minus 4. Yeah. So here we're going to use two rules of differentiation. This is a fun question. So remember, our dy by dx for the quotient rule is just going to be v du dx. Remember, v comes first, minus u dv by dx, all divided by v squared. Please try to internalize and know these formulas by heart. They will help you along your line. So let's take our u to equal 5x squared plus 2, right? And take v to equal 5x. Oh no, let's take r. Let's not use v. Let's use r. 5x squared plus 2 squared, right? So if u is equal to 5x squared plus 2, our r is going to equal to u squared. Do you understand? So I'm going to explain the logic behind this. It's because here we have a chain rule, and here and in total we have a quotient rule. So we're going to use both the chain rule and the quotient rule in this function. So if we have our u equals this, our du by dx is just going to be 10x. Remember, the derivative of any constant is 0, and since our r is equal to u squared, since we said let r equal to this upper function and let v just equal to this lower function, so let's leave this lower function first. Let's deal with this numerator. So if r equals to u squared, so dr by du is just going to equal 2u. So now we can use the chain rule formula for this. So the chain rule formula is just going to be dr by the x is going to equal dr by du times du by dx. I hope you get the logic. So we basically set this upper function to be a function on its own. That's r, function r, because we cannot set it to equal y, because y is this whole function. So we cannot say y equals this. So this will be left alone, and that's an error in solution. So we basically set this upper function, this whole numerator rather, to equal a function, and that function we said it should equal r. So that would be r equals 5x squared plus 2 raised by all raised by 2. That's this. So in order to use the chain rule for this, we set this internal function or this inner function to equal u. That's 5x plus 2. And when we differentiated it, we get 10x. So if this internal function we set it to equal u, this becomes r equals u raised to the power 2, a typical chain rule function. So then we use the chain rule to solve it. So we already got our du by dx. We now need our dr by du. So we differentiate r with respect to u. So dr by du is just going to be 2u. Then we use our chain rule function. That will be dr by dx is equal to dr by du times du by dx. Now normally the chain rule function is dy by dx is equal to dy by du times du by dx. This dy and du, they could be any variable of your choice, so it doesn't really matter. They are not really fixed variables, so they could be dx, it could be dw by dx, it could be dz by dx. It doesn't really matter. They are just they are variables that can differ and vary depending on the context of the question. So we have our dr by dx, to equal dr by du. What's our dr by du? That's 2u. So we have 2u times du by the x is 10x. So remember, our u was equal to 5x squared plus 2. So our dr by dx is equal to 2 times u is 5x squared plus 2, then multiplied by 10x. This is going to equal 20x open bracket 5x squared plus 2. So yeah, that's that. So now let's deal with this our friend down here. So if we say, let's draw a line to avoid a clash. If our v is equal to 6x minus 4, what do we do to get our dv by dx? We just differentiate it. So dv by dx is just going to be 6. So now we can deal with this formula. Our dy by dx is equal to v du by dx minus u dv by dx all over v squared. Now we do not have a u here because we already used u to solve this. So let's just call this our dr by dx. Yeah, and this will be our r, since it was r we used to establish or to define this upper function. So our dy by dx is going to equal, our r is what? This upper function here. This papa here is our r. So it's going to be 5x squared plus 2 or raised to the power 2, then du by dx, wait, oh my bad, this is supposed to be v, I apologize. So v is 6x minus 4, so our dy by dx is just going to be 6x minus 4, then times du by dx is supposed to be dr by dx, and this is dv. Sorry, my bad, I apologize. So yeah, remember this dr by dx is just the derivative of this upper function, and our dv by dx is just the derivative of this lower function, because we set this to equal r to use it, so we would have used it, so it will be so it was easier to solve the this using the chain rule. So 6x minus 4, then multiplied by dr by dx. Dr by dx is just 20x, then multiplied by this. So we have 20x open bracket 5x squared plus 2, then minus u. What is our u? We don't have a u. This is supposed to be r, since r is our upper function. This marker is gone. This is supposed to be r, since r is this upper function. This is r, this is v. Yeah. So minus r is 5x squared plus 2 raised to the power 2, then multiplied by our dv by dx. That's the derivative of this lower function. That's just 6. Then divided by v squared. That's just going to be 6x minus 4 raised to the power 2. Let me get more space. Yeah, so our dy by dx from the last question is going to equal 6x minus 4 multiplied by 20x open bracket 5x squared plus 4, then minus 5x squared plus 2. Sorry, 2 is 2 plus 2 all raised to the power 2 times 6, all divided by my god, this marker, all divided by 6x minus 4 raised to the power 2. Let me get to the marker. Yeah, 6x minus 4 raised to the power 2. So let's simplify this. This question was a bit messy, so take another question as last example. So we have 6x minus 4 multiplied by 20x into bracket 5x squared plus 2, then minus 6 times 5x squared plus 2 all squared, all divided by 6x minus 4 all squared. So let's simplify this friend here. So it's going to be 20x open bracket 6x minus 4 times 5x squared plus 2, and minus 6 open bracket 5x squared plus 2 all squared, all divided by 6x minus 4 squared. So this is our final answer. So this question was a bit messy, so let's treat one last question as our example. So let's see, we have something like y equals 92x cubed divided by 3x squared plus 1. So remember, let's set this to be our u, and let's set this to be our v. So the quotient rule formula is dy by dx is equal to v times du by dx minus u times the v by dx, all divided by v squared. So let's do justice to top and bottom. So since our u is equal to 92 x cubed, our du by dx is going to be 3 times 90, 270, 3 times 2, 6. So that's 276 x squared. So that's our du by dx. So and if our v is equal to 3x squared plus 1, our dv by dx is going to be 6x plus derivative of any constant is 0. So let's plug these values back into our formula. So dy by dx is equal to our v, that's 3x squared plus 1, multiplied by du by dx, that's 276 x squared, then minus our u, that's the numerator, 92x cubed, multiplied by dv by dx, that's 6x, all divided by v squared. Our v is 3x squared plus 1. So our dy by dx is equal to 276 x squared into bracket 3x squared plus 1 minus 6 times 92, that's 6 times 9, that's 5. 6 times 90, that's 540. 6 times 2, that's 12, that's 554. Sorry, that's 552. Sorry. Yeah. So we have 552 x times x cubed is x raised to the power 4, all divided by 3x squared plus 1. Yeah, 9 times 6, that's um for 540. Yeah, 90, yeah, 552, yeah. So this is our final answer. So the derivative of 92x squared x cubed divided by 3x squared plus 1 is equal to 276x squared, open bracket 3x squared plus 1, then minus 552x raised to the power 4, all divided by 3x squared plus 1, all raised to the power 2. Thank you for watching and see you in the next video.